Hello.
Hello, Tal.
Good morning, everybody. Here's John.
Hey, Tal.
Hey.
I had that my work laptop seems to be not behaving well. It's not starting up, so I'm on my personal laptop. We'll see.
Well, you're looking more personal, so.
Do you think so? I'm more relaxed right now because I'm on my personal machine.
Exactly. So we have two demos on the agenda today. But Vim, is it okay if I ask you to go? Is Vim here yet? Not yet. Okay. I do want Vim to go first because I just saw a little issue with Multis on this cluster that I'm working on.
Still coughing?
Yeah, I'm feeling better, but something, still something.
I guess we're waiting for Wim.
I guess so.
Anyway, John, while we're waiting, it was the ARM image, I believe, that was giving me a problem because I switched to my Intel MacBook Pro and it worked just fine.
Okay.
So there's no ARM image. I have a Apple MacBook Pro M1, and I'm also trying to use a VM.
If you use Kind, it works. But if
Okay.
you manually create your own VM and then install Kubernetes and then try to install Porsche, I tried it with version 008 and 0012, and both gave me both failed to install properly.
Okay, so using Kind still works.
Yeah, using Kind for me work.
Okay, that's what I plan. I'm actually setting up on my MacBook. Okay, thanks.
Which is odd, but sorry.
Oh, I was just saying I'll ping Wim on
Oh, he
Slack.
just joined. He just joined.
I'm here. Sorry, I was a bit late. I was on another call.
Oh, that's okay. Hi, Vim. I hope it's okay if I ask you to do your demo first. I'm trying to fix Multis while we're doing this on this cluster. That
not a problem. I don't know whether it works right now, but
well, the demo gods will decide.
Indeed. So yeah, I think it should work. Share screen. Right. Yeah. Okay.
Should we give some context, Wim, as to what this is?
Yeah, so I will first go through the, what is it, open system preferences. Oh my God. Doesn't allow to share. Load to record content of your screen. Even when using the app, it seems I need to restart. Share desktop. Should be possible, right? Open system preferences. Welcome. Let's unlock.
Hello, everyone. This is Bala.
I'll restart, but I'll be back in a
How about meanwhile, John, we can give an update on what's going on with the workshop meetings that we've
Sure.
been having on Friday.
Well, I wasn't at the last meeting, but I will tell you, I can give an update as to what I'm up to. So I've got Stephen and I met yesterday, and I met I know there's discussion happening on the Slack channel. My plan today is to nail down what I think like the detailed user journeys should be, which I think will flush out any additional pieces we need. Like I feel like the piece Wim's working on here for IPAM is one that's part of that. I have Natasha from the Porch team working on some tweaks to that that controller. So we have a document for the folks who haven't attended the other meetings that describes sort of what we want to do in scope, but it's still pretty much, it doesn't sort of go into the details. And so some of the pieces we need done for that are the kind of some cleanup on that piece from my old demo a couple months ago. We need the IPAM piece that Wim's working on. We need the pieces that Stephen put together around UPF. And we want to integrate all of those things together. And there's also an SMF piece, which Stephen said Anne was interested in working on. I don't know what this what's happening with that, whether that's true.
Yeah, actually, so for that piece, there's a CLD resolutions on the management cluster. I think Anna and I will talk about today, and hopefully get her going. And then Michael Park, who's also in this meeting from Google, he's going to work on adding a SMF deployment CLD support onto the 3.5GC operator. So
okay, awesome.
We'll get that going.
Several other community members are pitching in and working through integration pieces. And so I hope that by the end of today, and maybe certainly for our next Friday meeting, we'll be able to have a clear path to what we're going to do and all the integration pieces there. So that's my the view I have of it, Tal, but given that I wasn't there Friday, maybe you can update me more on as well. Oh, and as far as logistics, we had talked about a few different things. And I'm hoping that maybe just each person gets a big VM with three or four kind clusters on it might be the simplest thing. And so we're going to try that out.
Why do we need 3-4 clusters? I thought just 2 clusters, right? Or...
So I guess in my ideal world, we don't need it. In my ideal world, though, we'd have a management cluster. We'd have a cluster that represents sort of a regional cluster where the SMF could run. And then we'd have clusters representing like aggregation layer clusters where the UPFs would run. But
oh, okay. So you want 3 tiers of cloud kind of thing. Okay.
That would be ideal. I mean, I don't know if we can really do it in the time frame we've got. But...
Okay. No, that's what I was asking, to at least come up with some diagram so that we know what the setup is.
That's what I'll work on that today. And anybody else is willing like to pitch in as well, but I'll be around all day.
I'll probably add my chip in my view as well.
Okay.
I'll work with John on this.
In the meantime, you should see my screen, I believe, or not?
Yeah, just a couple of questions there, Stephen. Yesterday, there was also point using the GK directly and letting the KDS using the IPAM management without the secondary interfaces. And is that just wanted to understand, are we based on what John said, we are not going that path? Just wanted to make sure that that understanding is correct.
Yeah. So we take the shortest path possible, which is the easiest path possible. So right now, if Porsche can run on kind, giving individual access to VMs without any network problems, if you will, out of that VM would likely be the simplest path possible. Although they still need network, they still need to read the repo.
Yeah, I mean, we still have, like, if we have multiple clusters, we still have to do networking. My assumption is that we would statically provision some subnets for cross-cluster traffic, like between like multi-subnets that I don't know. Like maybe we need to. This gets back to what Wim's about to demonstrate. Like if you think about like on those secondary interfaces, you want IPs on the same subnet so they can talk to each other at layer 3, but something has to plumb the connectivity between the kind clusters. And I was assuming we would statically do that right now because we're not doing transport yet. But that, I don't know what other folks think. We need to get something working in such a short time.
Yeah, actually, I never done kind cluster one node from kind cluster accessing those from other kind clusters, even though if you expose the server. So yeah, we have to explore how that works too.
Because I know with kind clusters I believe we don't have any load balancer provisioning. So you don't have like service type load balancer.
Yeah, you can have a metal LB, by the way. Yes, yeah.
Running
Or-
all the same node
yeah.
or
Yeah, not a problem.
okay. All right.
cool.
Well,
Okay.
so let's nail that down in the next day or so we can make it work.
So, I just wanted to highlight one advantage with John's what said his that single VM could also be the jump host VM where the user can log into, where all the kube config files are there to access clusters. So we don't need a separate one. So that basically users will jump to that, and based on the kube config, they will access the clusters. I think that's also possible in this approach.
Yeah, I would thinking we'd actually just create a VM per participant, and we can even just give them external IPs. I don't know what that costs. 90 or 100 external IPs might have some nominal cost, I would think, but just a day, I can't imagine it costs much. But worst case, we can create one jump host that then everybody can SSH to all the other boxes. But anyway, I'm hoping also to have a UI journey with it. So we're gonna fix that issue where the UI needs Google authentication and just use a service account, so it will be no authentication. And that will simplify that too. So I think we can actually have a UI component to the story too. So I'm trying to nail all of that down, what I think we should do today, and we can all discuss it on Friday or over Slack before that.
Thanks, John. Yeah.
Yep. Okay. Sorry, I didn't want to take over here. So
We may to be a little less ambitious, but yeah, go. Go ahead, man. Sorry.
Yeah, so, okay, put some context. Maybe I'll start with this. I think I try to represent in this graph or in this thing what we have today, right? It's basically, we have a deployment that triggers a deployment reconciler, which takes in repo configuration and a UPF class. And at the end of the day, we want to render an NAD and a deployment manifest, which has IPs and so on and so forth, right? So I'm focused on trying to have a way that the IPs which today into the, if you try to deploy what Stephen shared, the IPs are all hard-coded, right? So what I've tried to focus upon is, okay, how can we plug in an IPAM system into that natively and try to get that integrated such that the let's say the dehydration, or when you get from the config to the actual deployment, that all these IPs are dynamically allocated through a native KRM based environment. So I created a project, an IPAM implementation. And there's actually two components to it. The first component, so the first thing so this is the README of the repo. By the way, I'll share you the link because it's public. So the code is publicly available. It's on the Nokia repo right now. So, but I can share you the link today. So what I did is there is a concept of what I call virtual networks to allow for overlapping IP. So I think of these as like a routing table in a VPC. So it's like a VPC that we have, and so we need to connect to that. I'm not doing anything to set up that network, but I'm using it to provide an IPAM context to allow for overlapping IP. So if you create a V4 or V6 address, although for V6 it's not really needed, but for V4 it might be needed. So you basically create your IPAM system, or you can create it. No, you have to create it in a network context, which basically is implemented as a routing table at the end of the day, right? And if you need overlapping IPs, you need another routing table to allow that. So what you do is you create another network context to actually do that. So as such, I support IP addresses. So an address is, I classify them as a /32 and a /128 for IPv4 and IPv6. That is prefixes, which basically is an address which is non/32 and /128. In the API or in the CRD, there's no distinctions between the two, so it's all the same. So you have a prefix and you can create them, but just for explanation purposes, I do that, right? Then there is a concept of pools, which we probably need for UEs. Again, a pool is implemented as a prefix. So again, the API doesn't distinguish that. There is just one parameter that basically allows what's the difference between a prefix and a pool. Typically, the first and the last address in a regular prefix are not usable, whereas in a pool they are. So you allow for that capability. And then I had the idea to implement ranges, but I didn't do that yet. So all of this is accessible through a Kubernetes, so modeled as a KRM through CRDs, and which I represent here into the drawing. So there is a network instance construct, there is an IP prefix instance construct, and there is an IP allocation construct that I will explain in a bit. Now, so there is two ways to consume the system. So typically what you do is network instance and IP prefix is the construct that you use to basically an admin provisions these ahead of time for people to consume, right? So you basically say, so in the case of the demo, I think at the moment, Steven, if I'm right, you create 3 networks. They all have different IPs at the moment. So what you would have to do if you put them on all, so you have 2 choices, or you have multiple choices, basically. You could say, I create them all in a dedicated network instance, right? So you create 3 network instances. So that's one option. And you create 3 prefixes. They all come from the same, from a different IP, but you could, for example, use overlapping IPs if you want. And so you have the flexibility to use these constructs. So basically, yeah.
So can I just for my own sake, a network instance is basically a layer 3 address space. It's like a named layer 3.
Yes, it's like I call it a routing table in a VPC, Okay. So you have a routing table.
Within a network instance, all IPs are unique.
Correct.
Okay, thank you.
Correct.
And that's its defining characteristic.
Yes, yeah, correct.
Okay, awesome, thank you.
Yeah, so the routing table that I was referring, by the way, I use GoBGP routing table under the hood, and we just added labels to it. So basically, a network instance is a routing table in the implementation. Yeah. And then prefixes are entries in the routing tables, as well as addresses and prefix and pool. They're all entries in the routing table, basically. And of course, if you want 2 overlapping IPs, you cannot put them in the same routing table because there can only be one, right? So you have to get another routing table to do that. That's basically the idea. So I think the thing here is that I use labels for all the, let's say, selection criteria as well. So the labels are used all over the place because that's what Kubernetes uses. So we use labels as selectors. So you basically can set up your IPAM with certain names and so key values. And when you do an allocation, for example, you can basically refer to that label or that key value pair and basically use it to basically select the IP address from which you want to get the IP from, right? So that's kind of the construct. There is also the ability to add metadata at the regular, so in metadata fields, there is the regular label construct that we have, and that I also use to augment. So this is kind of metadata on the prefix that you add in order to get some context of that. And you could also use that in the selection if you want. So it's rather flexible to be able to support that. So, but everything is based, all the selection is based on labels with key value pairs. So V4, V6, both supported out of the box. And you can either choose single or dual stack, whatever you want to do. As I was mentioning, so you can consume the IPAM. So basically what I explained so far is the IPAM system as you see here, it has 3 CRDs. One is network instance, one is IP prefix, and one is IP allocation. What I also added is an ability to plug it into the demo, because what you see today when we do the, what I call the dehydration, when you basically say, here is a deployment, you basically create a cap package, and in the cap package, there is a bunch of network constructs being, let's say, consumed or allocated. What I'm envisioning how to integrate it into the current demo is that there is a controller, which I call a proxy, that basically looks at all of these repos, which have the IP allocation schema, and basically goes and allocates it. And there is a gRPC service, which I can also demonstrate, that is actually an implementation of the IP allocation. So you can, there is no difference whether you basically ask for an IP allocation through the Kubernetes API and apply that to the cluster, or when you ask it through the gRPC interface directly. So, but you will not see that as a consumer. You will not see that.
So in a sense, you're creating a gRPC, an IPAM sort of version of like CRI or CNI or a CSI, like a gRPC API that different vendors could potentially implement, and then your controller would be able to interact with any of them. Is that the idea?
Yeah, correct. So the idea is, as I showed in this picture here, okay, we have our own IPAM system, which is native Kubernetes, right? But probably the features, so if you have an info blocks or whatever flavor that people consume it, I'm envisioning that some people could say, okay, I don't want the native Kubernetes construct. I want to use my own IPAM system that I have already in place. So how do we make that work in that environment? So the idea is to basically use this proxy. That's why I call it a proxy, to basically interact with an API. And this would be a pluggable system to basically consume the API of, let's say, an Infoblox or whatever vendor, like Netbox or whatever vendor that is implementing that.
Cool.
That
okay.
IPAM
So yeah,
system.
so the controller sits between the packages that need IP addresses and the IPAM system, and you've got some general interface on the IPAM side, so that controller doesn't really have to change as you swap out different IPAM systems on the other side.
Correct.
Yeah. Cool. Okay.
So one more thing that is important. So if you look to the, I already mentioned it. So there is the implementation of the IPAM is a network instance. Actually, there should be an error. So that's basically a routing table, and there's a hierarchy of prefix. So for example, in the demo, I will show you there is a /16 and there is a /24 drawn from it. So you nest these prefixes together. So you can basically build a hierarchy. For example, in Netbox, they have this concept of aggregate prefix. So they always say, okay, here I have a 10/8, or I have a prefix that I got allocated from the RIR. That is my aggregate prefix. And then I'm going to say for this cluster or this site, I have this IP prefix, and for this one, I have this IP prefix. So you have a very flexible nesting system that allows you to build hierarchical IP addressing schemas that will be consumed then at the lower layers to draw IP addresses from that are allocated towards a particular interface of a network function for our purpose. Okay. So these are these constructs, the proxy I explained. So how does it work? So I try to document it. So what you do is you create a network instance. You can give it a name of X. So I call it network 1. Simple. Then what you do is you can allocate prefixes onto it. So what you do is you have an IP prefix system that basically, and I did something here which is still up for discussion. So I saw in the demo is you need a gateway, right? So one thing, so there is 2 ways that you can go about that. Is I allowed for this annotation. So for example, if you would say 10.0.0.254/24, for example, I would use that address here as a gateway automatically. So you don't have to do anything for it. I don't know whether you people like it, or I can also do explicitly configuring a 10.0.0.0/24. and then have a specific gateway object or IP that is drawn from it, explicitly configured. So I did a very user-friendly version, but of course there is a bit of things going on under the hood to allow for this construct. You can do both basically, right? But I took this one because I saw that in the use cases we need this gateway. And then I was under the impression that not everybody wants to basically create a subnet with a 0 and then an additional IP address, which would be a gateway IP. But these are all things we can discuss. So I allow it to be for people to basically configure that prefix with, let's say, with an address inside, and I'm using that address as a gateway implicitly. Not sure whether people like it. We can discuss. And then you can create a /16 and stuff like that. So that's basically, you set up prefixes. What you can, so what you then see, and actually this is actually live, right? So if you look kubectl get IPAM, so this actually, you see here, the prefixes that I actually have configured into the system. So if you want to have another prefix, I don't know, these are all YAML files. So if you say cut or copy network prefix X, to network run prefix 10, and I change it. You have to change the name, of course, because that's a unique key. And if you want 169, 192, yeah, you can do whatever you want. 168.0.1, part of network 1. And if you do kubectl apply -f of this prefix, YAML, then you see the upper side is doing a bunch of stuff. Maybe a little bit too much. I don't know what's going on. kubectl get IPAM. What you see is, what did I do? You see that here there's a new prefix that was added to the cluster. If you do kubectl describe network instance, and there is only one, you should see that, as I said, I'm using this thing under the hood. So, but you see that this is the routing table where you see all the allocations that are being used or consumed into the system. So you see that I'm adding automatically that /32, and I'm tagging it with the gateway attribute key value to distinguish it. So if people want to consume a gateway, they can basically take that up, right? So, but you see here, I have a /24 in it, and I have a 01/32 into it. So you have a /24 as well as a /32 that is, yeah, consuming that. I think, yeah, I probably have here a bug that it should be /32. Then, so this is basically setting up the system as is. What you then, so yeah, so this is the routing table that I just showed you. So now
one question,
yeah.
Wim.
Yes.
When you say routing table, are you talking with specifically in the context of a given edge cluster, or is this like a global routing table that can be potentially contextualized to every edge cluster?
So this can be contextualized to an edge cluster. So this IPAM, by the way, the IPAM system is flexible, so you can use it with an edge cluster or management cluster, whatever you want. But I'm envisioning it for this demo is we want to basically do the resolution as much as possible on the management cluster, right? That this IPAM will be used on the management cluster. So what you would have to do in that case, you would create a prefix for edge cluster 1, another prefix for edge cluster 2. And as such, you basically say, if I deploy on edge cluster 1, use this prefix. And if you deploy on edge cluster 2, use this prefix.
Okay. So in that case, you will see kind of two sets of routing tables for each edge cluster.
Well,
No. No. So you have the choice. So if you want those edge clusters to communicate, right, eventually the prefixes should be allocated from the same routing table.
Oh yeah, of course. Yeah, I mean, on the same virtual network, the IPs have to be unique. Now, I was just trying to say, when you say routing table, I was trying to understand routing table generally is deeply correlated with the forwarding with the FIPS.
No, I understand the confusion, but if you look to an IPAM system under the hood, it's a routing. They basically add prefixes and they create a hierarchy between them, right? So if you look to a routing table, it's the same. So I'm using a routing table implementation to implement an IPAM, but yeah. Now you can use it in the way you want to use it yourself. So for example, in other words, if you want to edge clusters to communicate, and they need different IP subnets on each side, right? You basically create a single network instance, create prefix 1 for edge cluster 1, prefix 2 for edge cluster 2. If you really want to have full isolation between the edge cluster and no communication, you basically could put them onto a network, onto their own network instance, and have even overlapping IPs allocated on both sides. So the system is flexible, so you can use it the way you want to consume it. So it's not constrained to any particular deployment model, is what I'm trying to say. In the context of Nevio, in my view, in this case, the way I envision it is that a certain network function will be, let's say, all the N3 interfaces, if you will, would be put onto the same virtual network. So they would be put on the same, let's say, network instance. And they would have dedicated IP prefixes from which IPs will be drawn, right? And as a result, they can communicate and so on and so forth. And then another N4 interface could be from a different virtual network instance that has then provides isolation. Right? Whether you then implement IPsec tunnels or VPNs or EVPNs or whatever flavor of the day, I don't care. It's a choice you have, right? So, but that's so I envision the system to be used in the context of Nevio as a network instance is a construct that allows people to communicate across edge clusters. And so if you want that to happen, you should draw IPs from that same network instance.
Okay, but I think you're still the problem of the transport underlying physical network connectivity is handled by some other intelligence, I guess. I mean, this is mostly handling the.
Yeah, so I'm focused purely on the IP because I believe one of the important elements is we want to have a pluggable system, right? And I also, what you see is that if you, I try to focus on doing one thing and one thing very well and not 5 things and do it all cluttered together because you get too much dependencies and inflexibility. So I build a pluggable system and the focus here is purely on the IPAM side. So I want to give you IPs and that's it.
Yes, got it. Yeah.
And then how you consume it, if we plug later on another networking construct into it, we should allow for that, right? Whether you use IPsec, whether you use EVPN, whether you use VPN, MPLS, SRv6, we shouldn't, the IPAM system should not care about it.
Yeah, and then, so I think you were about to show, like, you also built a consumer of this IPAM system that integrates it, or maybe you're building, I don't know if you built it yet, that integrates it back to injecting that configuration into the package as it moves through its configuration process in the management cluster before it even gets delivered to the edge cluster.
Correct. So I have a prototype. So it's already in this repo, and okay, we can split that part potentially, yes, because again, so this could be split at the moment.
Yeah. Well, what we'll do is we'll bring all this stuff into the Nevio project, and then we'll split it into different repos. But yeah, this is awesome.
I'll show you that in a bit, John. Right. So okay, how do you now? So what we have demoed so far is an ability to set up an IPAM system with IP addresses. Okay. Now, in Nevio, we have a network function that gets instantiated, and we need to allocate IPs.
Excuse me, could I ask a question if you don't mind?
Yeah,
sorry, I had my hand up. Maybe it's not visible, perhaps, but yeah.
Yeah, that's right. Not how I have to stand it. Sorry.
Yeah. So I guess I'm not totally clear about the focus or the scope of what we're trying to do here. if inter-cluster communication is part of your goal, as you yourself said, right, overlapping IP addresses possible, and we could do things like overlays with VXLAN or Jenny or whatever.
Correct.
So if you're saying that is not in the scope and you want to leave it to some other system, then the existing CNIs can handle IPAM within a single cluster. So I'm not sure what we're trying to do here.
What the IPAM systems cannot do today is like virtual overlapping IPs, right? So like virtual network constructs. Plus, you will see in a bit what I will show you next in the next part is you could have the system ask for specific IPs that are pre-configured in the IPAM system. So for example, you could say, I want this particular static IP based on labels that you have assigned. So for example, we could predetermine the IP address that is going to get allocated for a particular instance. So you have the flexibility to basically do that selection. Right.
I see. So you want overlapping IP even within a single cluster.
Or specific IPs that someone needs. So we want to have that all that flexibility to allow that for to happen. For example, to give you some context today is we want at the moment, for example, let's say we deploy an SMF and a UPF in 2 different edge clusters, right? Okay, I think Tal will talk about service discovery and stuff like that. But let's say we have a configuration, we want the N4 interface to communicate between SMF and UPF, right?
Okay.
Okay, so the UPF probably needs an IP for the SMF and the SMF needs an IP for the UPF, right? So to be able to allow that PFCP to happen. Okay, if you don't have control, so one way to do it is basically you say, okay, I get a static IP, which is basically predetermined and the system will give it. And as a result, all is done, right? That's one way that you can consume the system. I'm not saying that this is the way we consume the system, but it's one way that we can, that the IPAM can operate or you consume the IPAM system as such. As a result, you don't need any other construct than just that. You see what I'm saying?
Yep.
So all
Okay,
of
I
that
see.
flexibility. So these are all the flexibilities that we allow into the system to consume it the way we want to consume it. And I don't believe that the current IPAM systems have that all that juice or jazz right now.
So one of the ways I think about that is like what service discovery in general, or DNS, for example, is an indirection. And it's an indirection that's resolved at runtime. And I think my understanding is a lot of telco operators don't really like to use DNS because of failures, and resolving it at runtime has risks. What we're doing here is creating an indirection in the configuration with a resource that kind of just contains this metadata of that you're looking at on the screen right now, and then we're resolving it via the IPAM system at configuration time. So that by using an indirection, we can still do the configuration once and then let an automated system inject based upon and resolve that indirection at config time. But we don't have to sort of think of it all ahead of time. We can separate it out into the IPAM system. So that's how I think about it.
Okay. So one
Hey
quick
guys, I
follow-up
wonder
question.
if we have 20 more minutes. I'd like to add another demo if that's okay for today. It'll be kind of
we can finish.
Okay.
I quickly want to show. Yeah, so go ahead. In the meantime, I'll show this thing here, John. Basically, what this is very quickly is I have a directory. So I compare it to a package, right, which has a bunch of these IP allocation with a set of tags, right? And what I do here when I run this thing, it basically reads them. So it's similar to the package and goes to the gRPC through the gRPC interface and basically does all the allocation. So you see here all, my PC is a bit slower because I'm running too much on it, but you see here, so these are the IPs that we got allocated. So this is, and you see also the conditions.
We're seeing your GitHub screen. I'm not seeing that.
Wait, sorry, I was doing it on the wrong screen. So basically you see here that these are the IP addresses we got allocated. So these are the allocations that are in the package revision, if you will, right? Like this. And so what this program does, so if you run this, it basically takes those from the package revisions. It basically goes to gRPC, resolve them via iPad, and here you see we also set the condition to true if in case that resolution happened. So this is the way I think we have to integrate it into the demo. But sorry to interrupt.
Awesome.
You had a
Yeah.
question. So,
Yeah, is it okay? I know we have a hand up. Is it okay if we continue with the next demo in the interest of time? And we can continue to discuss on Slack. Vim, I have so many questions as well for you. So, but this is really great. It's actually somewhat complementary, I guess, to the demo I'll show now. So is it okay if I start? Or is
Go
there
ahead.
any lingering issues? All right. So
Yeah, that's great, Wim.
yeah, it really does. Yeah, I have a lot to say about service discovery, but yeah, I'll share my screen. All right. Hopefully this is my screen showing.
yes.
Yeah.
Yes.
Okay, excellent. So KNAP, let me just share the repo for whoever wants to follow. So it is a very lightweight and simple manager for Multis networks. And I'll just show you how it works instead of slides or anything like that. So if we'll dive right into examples, I'll show you how we do things today, usually in Multis. And I call this the explicit version. The way we usually do it, if you want to work with Multis directly, is you have to create these network attachment definitions, which have the JSON config of the CNI that you want. So here I'm creating two of them. I'm calling one of them explicit A, one of them explicit B. I think they're almost the same, except, and this is where it kind of attaches to Vim's demo right now, is that they have a different prefix. They have a different subnet, right? So this is 2.0, 198.68 2.0, and this is 3.0. And they have different gateways, of course. So we have those two networks. Then I'm creating two deployments. And the way it works, I need to put an annotation on the pod. And this is the standard Multis annotation for those who know. And here I put the name of that network attachment definition. So I have explicit A. So what I'm doing here, I'm creating two deployments. Each one of them is attached to a different network attachment definition. Now this works, right? If you deploy it on anywhere that has Multis, and you'll notice for the demo, I'm using the bridge CNI, which is just the easiest one to set up and use. And for this demo too, I'm going to be using Minikube that I've created. And sorry, I had some issues with it just before starting due to Multis version stuff. But the reason I'm using Minikube is just it's so easy. Well, if you do a bridge network on your local machine using Kind, you will have a bad time because you will be creating virtual links on your host system. This way, I'm doing it in a virtual machine, and I can just destroy it and don't have to worry about IP tables and virtual links and all the stuff that the CNI creates. So yeah, what's the problem here? Managing this at scale is extremely difficult because it relates to some of the issues Vim was talking about, because I need to write this. I need to know which other subnets exist on the machines, because this requires host knowledge of that particular host. If I'm packaging a CNF or any workload that requires these network attachment definitions, I need to make sure that other workloads on that node aren't overlapping with mine, right? I have to have admin knowledge of not only the cluster, but of that specific node within the cluster to know that there are no overlaps, there are no problems, there are no issues with anything else. Otherwise, it will break. Not only is this knowledge very hard to get, it's often impossible, right? Because if I'm packaging something to be portable, I don't even know what the remote cluster is going to be right there, right? If there's an edge cluster, I don't even know if the CNI plugin is going to be there to actually handle this type. I know very little about where it's going. So the question is, can we do better? Can we do something that could manage this at scale? So, last week we had the ENO demo, which I'm sorry, I was sick. I wasn't able to attend, but that gives a very comprehensive way to managing these fabrics, right? What I'm showing today with KNAP is something much more simple. So the idea is to really be able to generate these CNI configs for us. So I'll show you the nicer version. In the nicer version, instead of using network attachment definitions, we have a new CRD called network. And all we do is tell it which provider we want. So instead of a CNI plugin, we refer to network providers. This starts to look a little bit like Neutron and OpenStack, right? Where we have network providers. That's intentional, right? But this is a very different design. In this case, I'm just giving it the name of the provider, but I can also provide hints for the provider as well. So I can make specific requests of what type of network or what I want specifically from that provider. And those hints are provider specific, right? So if I have a Mac VLAN provider or an SRIOV provider, they would have their own hints that they can add. But those hints explicitly are not actual configs, right? They are specifically about helping that provider provide me the network attachment definitions that I need. All right, so instead of network attachment definitions, networks, otherwise, it's pretty much the same, and I just give it a different annotation. So there's a KNAP annotation with a network name, very similar to the Multis annotation. That's pretty much it. I'm going to show it running to you and then explain what's going on behind the scenes. So here I have my cluster. As I said, it's Minikube, and I'm going to deploy this. And I'm going to go very, very quickly here and show you what's happening during deployment. So I have the operator, the KNAP operator pod, and then I have the provider pod. Then you're going to see a bunch of pods for the hello world attachments. And actually, if you looked quickly, you saw that pods were created, and you can see one still being terminating, and then a new one starting. And I'll explain why that happens. That's a multi-specific issue. But if I go to any of these pods right now, oops, that's not what I wanted. If I go to this pod and look at its annotations, I'll see that I have, so here's the KNAP annotation. And what the KNAP operator did, it automatically created that network attachment definition for me. And it set the Multis annotation. So now Multis is the next operator on the chain here. Multis picked up its annotation and attached. Here I have the bridge attached, and you can see here's the IP address that I got. So Multis worked. And if I look at the other pod, you'll see that it has the different prefix, right? So because it's attached to the different network. So magical, it worked, right? How did it work? Well, the providers are plugins that handle those hints. So I'll show you some of the code for it. It's actually very, in this example, I made very, very simple code, right? I have, here I'm generating the config. And let's see here. Oh, I have state management for it, where I have a pool of prefixes that I give it in advance. This is hard-coded, but this is a demo, remember. In the real world, this will be configured some way. So it would know or be able even to discover which, at runtime on that machine, because it's running as a daemon set. So on every node, it will be able to discover what capabilities are there, what has been allocated or not been allocated. And it can atomically allocate one of those prefixes for any bridge that's being requested. Right, so you can easily imagine any kind of other provider doing other things related to the semantics of that specific CNI plugin, right? So if it's flannel, you know, if it's dealing with overlays or anything else, like this can be either discovered dynamically or configured in advance when you put in the provider. But you can start to see that this is network as a service, right? I'm asking network capabilities from it. I'm giving it some hints on what I want, what kind of network I want, and it provides it for me. And it attaches it to Multis, right? So the idea is that this just does the configuration, high-level configuration stuff, and lets Multis do what it does, which is actually manage the connectivity. So I sometimes call this Multis Part 2, right? Multis Part 1 is the Multis project, which actually does the technical container networking, connecting everything to your pods or your virtual machines if you're using KubeVirt. This is about managing these configurations at scale. What else should I show in terms of, oh, I wanted to talk about why it restarted those pods. So this is a limitation of Multis. Multis is not, does continuous reconciliation, but it doesn't know how to, it only catches pods when they're being created. I hope this is a limitation that can be fixed later on. Maybe it's already in progress. I'll have to talk to the Multis folk. But the problem is if the pod is created and then you add that annotation to it, which is what the NAP operator does, well, Multis won't catch that. So the only way to get Multis to catch that is to restart those pods. So that's why you saw that kind of quick thing going on there. I hope there's a better way to do this. I have some ideas. I've talked about it early on with the Multis folk. Yeah, this is not ideal, right? If pods are very lightweight, this is not a big deal. If pods are a bit heavier, it is a bigger deal. So you want to somehow generate that annotation maybe beforehand.
What is doing the restart? Is it your operator is doing the restart?
NAP operator is doing the restart. It's not trivial to restart pods in Kubernetes. You actually just have to terminate them. But because it's associated, so I'll say another thing too, and this is something that relates to Multis as well. These annotations can exist in multiple levels, right? If we go again to the examples, there are a few standard resources. So here, the resource is actually a deployment, and the annotation is kind of deep inside it, right? You have to kind of travel inside the deployment and look at the templates, right? And the same is true for daemon set and replica set, and pod, of course, is the lowest level one. But so KNAP needs to know about all these standard resource types. And by the way, Multis doesn't, right? Because Multis only deals with the level of pods.
So this is, if I can, this is super cool. There are a few things from my point of view that from a Nephew point of view, I think would be really interesting. One is integrating this not at the node level, but back in the management cluster at the configuration time. Now, of course, that presupposes that you have a planned set of networks as opposed to, and maybe you schedule to nodes that match them. So there's maybe other issues that brings up. But that would allow it, it would avoid potentially that issue you're talking about of pods needing to restart, although you still need to make sure that the actual networks are deployed at the time. So, but that, I think that's really interesting. The other thing that's interesting is you said, oh, this stuff is hard-coded now, would be configured somewhere. So this is, I think, where we get into our API design. So, and I don't know if you've brought this to SIG Network. I know there is some discussion, and we can talk with the folks, at least at Google. I know I can find out who's working on it. I don't remember it offhand. Talking about the possibility of designing an API to replace Multis that would be in tree in Kubernetes for multi-network, but this would be years off, of course, the way Kubernetes development works. But one of the things I think you could do in this API design is some of those things that you're hard coding now could shuffle off into like a network class type of structure. Like there's API design techniques that might allow us to make that configurable and consumable.
Yeah, absolutely.
By the point being configurable by different roles.
Absolutely POC. This is
absolutely
POC.
totally. You saw my POCs. No, that's totally understood. That's the you got to make you want to demonstrate the main thing, right? So, but like even just if we want to pull something like this into Nephew, which we might want to put some time into that API at that point.
Exactly. Yeah, I agree. I actually started, if you look at the source code right now in KNAP, I know Anne has done a little bit of work looking into it. You'll see that I started working on a gRPC API for it, and I ended up not finishing it. So right now it's not actually using gRPC to talk to the provider plugins. But there's also different kind of provider plugins you can have. You can have them running as their own pods. You can have them something running on the host, which is how CNI and CSI plugins work, right? As executable. Right. So there are a lot of ways to think about that interface, because the provider could actually be something very thick. It could be the fabric itself, the fabric implementation. right?
Sure.
So there's a lot to do here. And quickly, I just wanted to show, I'm showing you from 2 weeks ago, the planter demo that I showed was, you can see how it connects. In the planter demo, I showed a seed and I had something that I just called a network and there was a provider. This is kind of what I meant, that there would be something. So this is kind of the higher level stuff where you don't have to worry about what gets created first. Planter can have that knowledge of kind of a hard dependency and make sure that that something is created before something else, right? Planter can handle those kind of hard dependencies. But anyway, I want to point out that that issue with pods restarting is such a technical specific issue to Multis, and I'm sure it can be solved in a more cloud native way without reverting to these kind of trickeries, right? There could be a change to Multis that could actually continuously track and handle these.
Yeah,
correctly,
it's like Multis not following the principles of.
Well,
distributed.
there's a technical problem with container networking that if you already have a running container and you want to create another NIC, virtual NIC in it, that's the problem, right? So Multis, yeah, this is just has to do with the way in which Multis actually works.
It
right?
can't add that to the sandbox. It can't. Yeah. Okay.
I think it's
Right.
related to how the CNI works, by the way, because you basically get triggered from the instantiation of the pod. So it's basically
Right.
the CNI way that because you get a one shot and then you can do it or you can't. And
Right. And we'd have to plummet. It'd have to be CNI.
Yeah,
that's the reason behind.
Right. So yeah, that's like a separate issue that is worth discussing for sure. So that's it. I did fit it in 20 minutes. I hope it was clear what it does. And we can talk on Friday to see if this is actually a useful thing to add to our workshop demo. It's very simple to add. What I showed you today, you guys can run locally too if you have Multis with the Bridge CNI plugin installed. And if there's interest in it, we can talk on Slack and I can show you actually how to run it. And I hope you can see also the synergy that I'm seeing with Vim's demo too, right? This idea of dynamically allocating network related stuff, whether it's prefixes, whether it's IP addresses, right? Because inside CNI, there's already IPAM, right? But we know that it works through CNI plugins. I've always thought, and I agree with you, Vim, that we need a much more comprehensive way to handle IPAM that's not just for CNI, but for any purpose and it connects directly to Multis because you're dealing with these extra networks that are not handled by Kubernetes. So who's handling it? Is it the IPAM plugin for CNI? That's great, but we have more needs than just allocating that NIC, right? We have other IP addresses that we need to allocate. So anyway, we're at the top of the hour. I know there's no room for a lot of questions and discussions about this, but I'm going to be on Slack right now. And if people want to continue to talk, I'll be very happy to. And Vim, I don't know if that's true for you as well. If you want to continue to chat,
I have
on
one
Slack.
call and then in an hour I will be on Slack. So yeah, or if it's done sooner, I will be on Slack as well. So, but yeah, probably an hour at max, and then I'll.
Okay.
I'll be there.
Well, it can be asynchronous. So yeah, we should probably finish up. I think for next week we don't have an agenda set up yet, but I'm sure it'll be filled really quickly. ONE is very, very close. So that will be actually our last meeting before, right?
Yeah, I hope that we'll be able to do some sort of, I don't know that we'll be ready for a dry run yet, but that might be till Friday, like the last minute. But maybe Wednesday we can at least talk through the plan and figure out what needs to be done still. But I'm feeling pretty good, having talked to a number of people working on different pieces. So after today and anyway, we're out of time, but I think we're looking pretty good there. All right, thank you, everybody.
Thank you.
Thank you.
Thanks,
All right, have a good day.
Thank you.
Thank you.
Yeah.
Thanks for the
Thank
demos.
you.
That'll win. Bye now.
Thank you. Yep.
Thank you. Bye.
Thanks. Bye.